rouge se déplace naturellement.
There are other types of fires we can see too. So if we go back to Africa, the northern part of Africa, across to the Middle East, you see very bright fires. These are for oil extraction. These are places where the oil wells are flaring.
Donc les feux qu'on voit en nord d'Afrique, ce sont des feux à cause de l'essence, de pétrole.
If we zoom in perhaps to Iraq or Kuwait, and we turn on the visible satellite, if we zoom in enough, you can see it's a very dirty sort of fire on these flares.
Donc on a changé vers le satellite visible et on voit que les feux sont beaucoup plus sales.
If we go to the United States, first, there's some seasonal burning, not very much. But if you look here in Kansas and Oklahoma, once a year, those are cornfields burning.
Donc aux États-Unis, on voit au centre des États-Unis, à Kansas, il y a des feux qui sont à cause des feux de maïs.
But the three big areas you see for fires, those are 3 new oil fields in the United States, 2 in Texas and 1 in North Dakota.
Nous voyons en Texas et North Dakota plusieurs champs de pétrole qui sont assez nouveaux.
So today, these oil fields produce more oil than Saudi Arabia. If we zoom in to North Dakota, this is one of the fields that is now using a technique called hydraulic fracturing or fracking.
Donc
I don't know how to translate that.
Ni moi non plus. Donc ces 3 champs produisent plus de pétrole que même en Saoudi. Et ce que vous voyez en North Dakota, c'est un nouveau type d'extraction qui s'appelle en anglais fracking.
And when we...
C'est quoi? Facturation. Hydraulique. Ok. Merci beaucoup.
And most places in the United States, when we frack, we release methane or natural gas. In those 3 fields, we're getting more oil than gas. But the problem is, here in North Dakota, we get 1/3 gas, 2/3 oil. And all of the gas, there's nothing to do with it in North Dakota. There's no infrastructure for collecting it, for making use of it.
Wow.
So this 1/3 of the carbon that comes out of the ground is burned immediately into the atmosphere.
Donc le problème c'est qu'un tiers de ce qu'on extracte à cet endroit à North Dakota, c'est pas utilisable, donc on le brûle.
So let's look at other forms of carbon extraction on the planet. We're going to go to Australia, and we're going to switch to a new satellite. This satellite is called Landsat, and using Google Earth Engine, we're able to build 30 cloud-free pictures of the Earth starting in 1984 to present day. And what you're watching is a coal mine being built and expanded.
Alors, nous venons de changer de satellite. Il y a un nouveau satellite et on regarde maintenant Australie. Et ça donne beaucoup plus de détails. Et ce que nous voyons, c'est une mine qui a été... Which year was it?
Starting in 1984.
Qui a été créée en 84 et on voit que ça élargit. Sur une période d'une trentaine d'années.
So we're going to move back to the United States and see another form of coal mining called mountaintop removal.
Wow.
In mountaintop removal, literally the top of the mountain is removed to give access to the coal, and it's dumped into the valley.
Donc voici, nous revenons aux États-Unis et on voit un nouveau type d'extraction qui s'appelle l'enlèvement de sommet d'une montagne. Et voici, on voit qu'on enlève la montagne et aussi les déchets sont jetés dans la vallée.
Right now we're looking at 50 kilometers east to west.
On regarde 50 km de l'est à ouest.
If we zoom out, we'll see more mountains.
Maintenant, on voit plus de montagnes,
Maybe 200 kilometers east to west.
à peu près 200 km.
Oops.
Yes, that was.
So you can see the full extent over several hundred kilometers. There are hundreds of mountains.
Vous pouvez voir les effets sur plusieurs centaines de kilomètres.
If we move to Alberta in Canada, we can see tar sands being extracted.
Maintenant, on est au Canada où il y a des sables de quoi? De schiste, merci.
So this is a form of extraction that's even more expensive carbon-wise than North Dakota. Half of the fuel that comes out of the ground has to be burned to make use of the other half. So half of the carbon coming from the ground goes straight into the atmosphere.
Alors maintenant, c'est encore pire qu'auparavant. Il y a moitié de carbone qui va directement à l'atmosphère. Donc la moitié, au lieu d'un tiers, c'est la moitié.
So let's look at what's driving all the energy coming out of the ground. We're going to go look at cities.
On va regarder maintenant le pourquoi. Et c'est les villes.
Let's go to Shanghai. Shanghai grew the largest of any city in the world.
Donc Shanghai a eu le plus de croissance de toutes les villes dans le monde.
So you can see over the last 30 years, I'm going to actually pause it and start it. So if we start in 1984, you can see it's relatively compact. It was a large city even then. The present day, it's expanded and connected to all the cities in the area to make what we're calling a mega city.
Donc en 84, c'était toujours une grande ville, mais assez compacte. Mais maintenant, quand on regarde de 2012, c'est aussi large que ça connecte avec toutes les villes d'à côté.
Of course, it's not only China. Let's go look other places. If we go to Dubai.
Donc c'est pas seulement la Chine, on va au Dubaï.
In Dubai, we can see the Palm Islands being built, artificial islands.
On voit les îles artificielles.
We can go back to the United States and see Dallas-Fort Worth.
Texas, on va, Dallas.
Here we have Dallas on the right, Fort Worth on the left. If we zoom in, we can see the farmland converting to city.
On voit les fermes qui deviennent la ville.
If we pan to the west, now we're north of Fort Worth. Look closely for the white dots that appear. White dots everywhere.
Chercher les points blancs.
That's also hydraulic fracking. This is fracking for methane in Fort Worth.
Ce sont des points de fracturation hydraulique.
Let's look at another way to see the growth of cities. So if we go back and look at Dallas-Fort Worth, I'm going to switch to a different layer of data. This is lights at night.
Maintenant, on change de source de data. C'est quel était le nom?
Lights at night.
Des feux de soir.
And you've probably seen lights at night before, but this is a new way to look. We have data for over 25 years. In green, we have the amount of light stayed the same over 25 years. And in red, the amount of light increased. So you can see Dallas-Fort Worth getting bigger.
Donc on voit la quantité de lumière pendant une période. Donc le vert veut dire que ça a resté le même pendant une période et le rouge ça veut dire que ça a changé.
If we zoom out more to the rest of the United States, we can see other cities which have grown. We can see Atlanta, we can see Phoenix, and we can also see these oil fields that appeared in the last 25 years.
Donc, les grandes taches rouges sont les champs de pétrole.
Zoom out more, and we can see China, of course, is quite red. We see back to Shanghai.
Wow.
Only this part is unchanged. Everything else has grown.
Ouais, donc, seulement le centre de Shanghai n'a pas changé et le reste, bien sûr, il y a des changements.
In contrast, Japan stayed about the same the past 25 years.
Mais bien sûr, le Japon n'a pas changé plus ou moins pendant les derniers 25 ans.
If we move to Europe, take a look at two places here. Up on the top, the big red country, that's Poland.
En rouge, c'est Pologne.
And the blue area, we don't see much blue on the globe. Blue is where the light has become dimmer, but this blue area is Ukraine.
Donc le bleu veut dire moins de lumière, et ça c'est l'Ukraine.
So we're going to go back to Landsat now, the 30-year visible animation, and we're going to move to Brazil.
Et donc on revient à Landsat, donc on voit l'animation pendant 30 ans.
Now we've zoomed into as small an area as we can with Landsat, and we froze it back in 1984. We're in the middle of the Amazon rainforest in the Brazilian state of Rondônia, and so far you don't see much other than forest. So this is original forest.
Donc on voit l'Amazone en Brésil, il y a 30 ans, 84, il y a très peu de choses, seulement la forêt.
If we move forward about 5 years, we see a road being built, several roads.
Puis 5 ans plus tard, on voit des chemins.
A few more years and we see a small town starting to be built right here.
Quelques années plus tard, une petite ville.
Move forward to about 2000 and the farms start to get larger. So we're converting forest into farmland for beef or soybeans typically.
Donc on voit les fermes deviennent de plus en plus grandes pour l'élevage d'animaux et le soya.
And move forward to present day, almost everything is farmland now.
Et maintenant c'est presque tout ferme.
Right now we're looking at about 50 kilometers east to west.
C'est 50 km de l'est à l'ouest.
Now we're looking at maybe 200 kilometers east to west.
200 km.
Now we're looking at the entire Brazilian state of Rondônia, maybe 1,000 kilometers east to west.
Tout l'état de Rondônia, Brésil, de 2000 km.
Now we've zoomed out enough, we can see the entire Amazon River. We can see the rainforest and the arc of deforestation along the entire southern extent.
Donc on voit tout le fleuve d'Amazon et l'arc de déforestation partout dans l'Amazon.
Now, as with the growth of cities, there's another way we can look at this. I'm going to turn on an analysis layer built by Matt Hansen of University of Maryland, forest loss by year. And what we see in the colors is yellow represents trees that were lost in the year 2000, and red represents trees that were lost in the year 2014, and the yellows and oranges in between are years in between.
Donc,
Sorry.
nouveau niveau de data et ça montre la perte des arbres dans une période spécifique. What was it again? 2000, 2000 it was.
2000 is yellow,
Donc 2000 c'est en jaune et
2014 is red.
2014 c'est en rouge.
Now you can see, I'm going to turn back. You can see that in Rondonia, there's more yellow than red. And what that means is that more trees were cut down in 2000 than were cut down in 2014. The rate is slowing down.
Donc en Rondonia, toujours en Brésil, on voit que la majorité des arbres qui ont été coupés étaient coupés en 2000 et bien sûr toujours quelques-uns en 2000.
And in fact, if we zoom out, that's true most of Brazil. So Brazil is slowing down its rate of deforestation.
Donc c'est vrai presque partout dans le Brésil que le taux de décroissance de forêt en Brésil ralentit.
If we move more south to Paraguay, for example, Paraguay is more red and orange, so it's actually speeding up its rate of deforestation.
Par contre, en Paraguay, la croissance continue et la vitesse de déforestation augmente.
And the same in Indonesia.
Et pareil en Indonésie.
So we've seen carbon that we're taking out of the ground and burning. We've seen loss of forest. We've seen some of the reasons for that as we increase population and grow our cities. Let's take a look at what this results in. We're going to look at a graph of carbon dioxide in the atmosphere over time.
Donc on regarde le taux de carbon dioxide dans l'atmosphère sur une période de temps.
And we see seasonality in the northern hemisphere. Every summer it goes down when the plants pull the CO2 out of the atmosphere, and every winter it goes back up.
Donc on voit la saisonnalité que le CO2 va et vient chaque année.
But what's of most concern is the overall trend going up.
Mais le problème bien sûr c'est le trend vers le haut.
You can see in 1980 we were below 340 parts per million.
En 80, on était dessous 340 parts par million.
And today we're over 400.
Et aujourd'hui, on est au-delà de 400.
Now we've been measuring carbon dioxide in the northern hemisphere since 1960. We can play backwards and see that in 1960 we were below 320 parts per million.
On voit qu'en 60, on était en dessous de 320 parts par million de CO2.
We can go back earlier using ice core samples from Antarctica, and we can see that before the Industrial Revolution, we were around 280 parts per million.
Donc grâce aux extraits de glace au Arctique, on peut voir même bien en amont qu'on était en dessous de 280.
Now, as we know, carbon dioxide will tend to cause the Earth to heat up. Let's take a look.
Le CO2 cause la chaleur de la Terre.
This animation comes from Berkeley. It's called Berkeley Earth. And what we're seeing is temperature over time, starting in 1850, normalized to the temperature in about 1950. And we can see that it was colder before 1950.
Donc on voit les températures qui sont normalisées sur l'année 50 et on voit que bien sûr maintenant on est bien plus chaud qu'en année 50.
And from 1950 to 1970 or so, the temperature plateaued for a little while.
Il y avait une période de manque de changement entre 50 et 70.
And then since then it's been getting hotter and hotter.
Et depuis ça devient de plus en plus chaud.
You can see that the heat is not evenly distributed across the globe, especially the North Pole gets hotter.
Donc les changements ne sont pas équivalents sur toute la Terre et c'est bien sûr au nord de la Terre où les changements sont beaucoup plus grands.
Let's take a look at the sea ice. This is an animation from NSIDC in the United States.
Maintenant, on regarde la glace dans la mer, et ça vient de NSID aux États-Unis.
And what we see in 1987 is that the ice covered most of the pole. We see different colors for different age of ice. The white ice is the oldest ice. It's 10 years old or older. The dark blue ice at the top is the youngest ice. It's maybe only 1 year old. And it turns out the older ice is also thicker. So as we watch this animation, we all know that the extent of the ice will become smaller, but watch what happens to the age or the thickness of the ice as well.
Donc on regarde la glace en 87 et la glace qui est en blanche, ça veut dire plus vieux, donc à peu près 10 ans ou plus. En bleu, ça veut dire même seulement 1 an. Donc nous comprenons que la glace devient plus petite, mais ce que nous allons apprendre, c'est aussi l'âge de la glace change également.
Oops, sorry.
The Republicans watch this?
Oh.
Yeah, good question. Yeah, I don't know. I doubt it.
Oh, that's the end. Okay, sorry. Yeah, so you can see now, present day, the ice is smaller, but it's also, almost none of it is still that 10-year-old ice. So it's also become much thinner.
Oui, donc la glace maintenant est beaucoup plus jeune, mais hyper important, c'est que ça veut dire que c'est beaucoup moins épaisse.
Looking at the ocean, we see two things happening in the ocean. The oceans become hotter, and they also become more acidic as the oceans absorb carbon dioxide.
Donc les océans deviennent plus chauds, mais aussi ils ont beaucoup plus d'acide.
This is a 2-year animation from NOAA in the United States showing the risk to coral reefs.
Donc c'est une animation pendant une période de 2 ans qui vient des États-Unis, qui montre le risque des comment dire coral reef en français. Comment? Des pariens de corail. Merci.
And what you want to watch for as we move forward will be the red and the dark red, which will be areas that are very inhospitable to coral.
Et donc le rouge et le marron veut dire les endroits où le corail ne peut pas survivre.
So we're now reaching the end of 2013, entering January of 2014, halfway through 2014, and we start to see really dark areas. Now we're in 2015, as we move forward, you can see now we're in October of 2015, very recent, and we have a large part of the ocean now is very difficult for coral to live in. You may have heard about coral bleaching. Coral bleaching shows the damage to coral, and we're seeing one of the largest bleaching events in history right now.
Maintenant, à la fin de cette période, on voit qu'il y a beaucoup de rouge et marron, et ça montre qu'il y aura de blanchissement, blanchissage de corail. C'est difficile.
So we can. I don't. So you're asking about the Red Sea specifically? So I don't know specifically about, but we can. After we're done, we can zoom in and take a look at different spots. If we go back to Landsat, we can see different signs that the planet is getting warmer. There are 120,000 glaciers across the planet, and the majority of the glaciers are shrinking right now.
On voit qu'il y a 120 000 glaciaires dans le monde, et what was the last part?
The majority of the glaciers are shrinking.
Oui, et la majorité devient plus petite.
That just go away. Like
So what we're seeing here, this is Mendenhall Glacier. No, I'm sorry. This is Columbia Glacier in Alaska, and we see it retreat about 20 kilometers in 30 years.
On voit que cette glacier fait la retraite pendant une période de 20 years, 20 ans.
The end is so dramatic.
Here's another glacier also in Alaska. This one is Mendenhall Glacier. Mendenhall Glacier has retreated about 1 kilometer in the past 30 years.
Donc cette glacier a fait une retraite d'1 kilomètre dans les années.
We can look at other forms of water on the planet. Let's look at liquid water in northern Iran.
Maintenant, on regarde de l'eau liquide au nord d'Iran.
We're going to look at Lake Urmia. And you can see that Lake Urmia is shrinking almost to zero. Now the story why this is happening is complicated. In part, it's shrinking because too much water is being taken by these agricultural areas, so the water is being diverted on the way to the lake.
Donc cette lac est en train de disparaître effectivement pour plusieurs raisons. Donc une raison c'est à cause des fermes qui se trouvent juste à côté et qui enlèvent de l'eau.
If we move to the Aral Sea is the same sort of thing at a larger scale. And here we see clear signs both of overuse from agriculture, but also from drought.
Donc cette mer, ça disparaît pour deux raisons. C'est bien sûr toujours les fermes, mais aussi le drought.
Let's zoom into this agricultural area to the south of the Aral Sea and watch closely. So we started in 1984, it moves across and then it comes back. So watch that today these fields have gone back dry again and turned back to sand.
Donc cet endroit agriculture a élargi et est devenu le sable encore.
We also see places on the planet that become more susceptible to fire. Let's go to the southern part of Australia.
Donc il y a des endroits qui deviennent de plus en plus susceptibles au feu naturel. Pas exactement naturel, mais...
You can see each year different fires, and the fires uncover the white land below. So you might expect the fire to turn black, but in fact, in this case, the fire turns white.
Donc la terre devient blanc et pas noir après le feu.
In Colorado and the United States, we see insects that now are killing trees. This is the insect called the bark beetle. And the bark beetle used not to be a problem in Colorado because the cold winters would kill it, but not anymore.
Maintenant, il y a des insectes qui peuvent tuer des arbres qui auparavant n'étaient pas un problème, mais maintenant il le devient.
So this area here in yellow is area that was killed by the bark beetle.
Donc ce que vous voyez en jaune, c'était tué par ce bark beetle.
So I don't want to end on a down note. Let me go to one positive story, please. If we go back,
Une histoire positive pour terminer.
Just one?
if we go back to Rondonia, let's take a look. You remember how we noticed in Brazil the rate of deforestation is slowing down.
Donc le taux de déforestation au Brésil ralentit.
Look closely at the shapes that start to appear in the forest.
Regarde de très proche les tailles de ce qui disparaît.
I'm going to turn on a new map, which is a database of protected areas that have been compiled for the entire planet by the United Nations.
Donc maintenant, on regarde un plan qui montre les endroits protégés partout dans le monde.
Most of these areas now legally belong to indigenous peoples in Brazil who have won the right to protect their own lands.
Donc ces endroits appartiennent aux personnes indigènes au Brésil.
This particular area belongs to the Surui people, and you can see they do a pretty good job of keeping their forest intact.
Donc ceci appartient aux Seroui et ils font un bon job de le protéger.
There are some places in the south and on the west where there's some incursion. At this point, the Surui people have moved most of their population onto the border to protect the forest at some risk to themselves.
Donc il y a des endroits où ils ont peu de mal à protéger, mais ils ont mis leur population sur les bords de l'area protégée pour le protéger, mais même avec des risques à eux personnellement.
So we see in this way that governments and individuals can make choices that change our trajectory.
Donc les individus et les gouvernements peuvent prendre des décisions qui peuvent changer la trajectoire de notre vie.
That's the end of our tour. I encourage you to stick around and ask questions. We can also move this over and you can take a look and zoom in any place on the planet that you want to see. We have the video that covers the entire planet. You can go look at the Red Sea.
Si vous avez des questions, restez ici.
Great.
Oui,